Hello everyone, my name is Ankitha. Today I will be talking about hammer mills, which are one of the oldest and commonly used size reduction machine. So what are those? So this machine is basically it consists of a steel drum, and it has vertical and horizontal rotating shafts inside them, and each shaft contains around 4 to 5 hammers, which are made up of stainless steel, and they're used to grind materials like copper, brass, aluminum, computer parts, cars. So these hammers are basically rectangular pieces of steel, and they rotate inside this chamber at a very high speed. And they strike each and every component of the materials with high force. And as they continuously hit the particle size eventually reduces. So this machine basically is used to break and crush solid materials, and it's used in mining. It's used for crushing down chemicals, for food and other constructional works, which we'll get into. So this is how the machine looks like, and these are the different parts. So first you have the feed chute, which is basically where it's like an opening where we put our materials in. And then you have the discharge chute right here, and this is where the crushed material leaves the machine. And then of course you have the hammer, and it's hammer is used to break the materials using great impact. And as I said, they're made up of hardened steel or stainless steel, and these blades can either be flat edges or sharp edges, depending on the type of the hammer mill. And then you have the rotating disc right here, and that disc contains holes for inserting your hammer rods. And then you have shafts. There's one shaft right there, and it provides a rotational power to the rotor disc. And then you have hammer rods, and they're used to place hammers between the two rotor discs. And then at the end, you have this thing called screen, and it's basically used to filter and allows only the required particle size to pass through. So this is basically a zoomed in picture of what's here. So you have the rotor disc, you have the hammers, and this is the casing where the particles hit, and this is the shaft. And in this picture, you can see the hammers itself. So you guys see one, two, three, and four hammers. So firstly, the materials travel down the feed chute, and they're first striked by the hammer, which breaks the materials into smaller sizes. Then the particle hits the casing, which is right here, which is the outer ring, and it further breaks into smaller sizes because the particles are hitting the casing with high force, and there's a greater impact. And the particles, of course, hit other particles, which eventually reduces the size of the material. The cycle keeps repeating till all the feed material is reduced to the required size. So the raw material is collected and passed through the screen, as I said, to filter any fine particles from the coarse particles. And if the desired size is not reached, the operator can adjust the speed and monitor the performance from the control box, which is located on the machine itself. So that's convenient. So as you can see in this video, it's very fast, it happens very quickly, and the hammers rotate at a range from 2,000 to 6,000 rotations per minute. And the hammers can rotate either in a clockwise direction or anti-clockwise direction. I'll quickly go over some types of hammer mills that we have. So firstly, we have the lump breakers, which are very different from other hammer mills because they're not used to reduce the size of the particle, but to grind the particle into a fine paste or powder. So for example, chemical salts or clinker ash, which is basically ash that you get from coal. So lump breakers could be helpful, and this picture represents the lump breaker. And then you have the pneumatic discharge hammer mills, and material, so this is used for material size reduction, and a process known as air evacuation is also done alongside. So from this, you get things like paper, green wood, biomass. And then you have gravity discharge industrial hammer mills, and this is used to crush glass, ceramics, or dry chemicals. And then you have the full circle screen hammer mills, which is basically a 300-degree rotating screen. And they're basically used to crush spices and grasses, so very fine particles. And then you have the horizontal in-feed hammer mills, which is used for crushing down heavy particles. So the applications. So where is it used? So definitely in the food processing industries. So foods like legumes, soyas, nutshells, groundnuts, different types of beans are crushed through hammer mills. In chemical industries, um, it's used to grind ingredients to a fine powder. In pharmaceutical industries, um, it's used to grind ingredients to a fine powder. So to put into a capsule. So if you break a capsule open, you see fine powder inside it. So that could be grinded through hammer mills. And then overused automobiles and also those junk parts, they could be crushed, and the crushed material is later sent for melting for further recycling. So some of the strengths is that it's cost effective because it runs on very low energy, which makes it cost effective. And it can grind many hard particles because it has a high angular velocity, which makes it easier for the motor to work efficiently. And it's also very easy to use. It's easy to monitor, and installing this is also very easy. As I mentioned before, there's this control unit, and the operator can do like control the speed, the particle size reduction, everything in a convenient way. And as you can see, these are not tiny, but they're pretty small compared to other machines. So they occupy very small space, and they're also easy to clean slash maintain. And some of the limitations is, so as you can imagine, grinding these huge particles through stainless steel blades at high speed, they produce loud noise, so it causes sound pollution. And also high amounts of heat could be produced while grinding these materials, and that could potentially be a problem, especially when it's done indoors. But other than that, this machine is very convenient and helpful. And that's it. These are my works cited pages, and thank you for listening.